Hi, my name is Leonard Stargott. I'm a staff engineer here at Linear Technology. Today, we're introducing the LT8610. This is a new 42-volt, 2.5 amp output synchronous step-down regulator that's easy to use, offers very high efficiency and fast switching while consuming only 2.5 microamps of quiescent current. Let's look at the key features. The input voltage range is 3.4 volts to 42 volts, making this part great for automotive and industrial applications. The LT8610 offers ultra-low quiescent current of 2.5 microamps. For example, with a 12-volt in and fully regulating 3.3 volt out with no load, the current consumed will only be 2.5 microamps. The output ripple and transient response remain excellent across all loads. The LT8610 offers high efficiency, up to 96% through the use of integrated low-resistance top and bottom switches. A fast minimum switch-on time of 50 nanoseconds allows reliable operation at high switching frequency, such as 2 MHz. This allows the use of a smaller inductor and helps avoid interference with the AM band in automotive applications. The LT8610 can operate with a low dropout of 200 millivolts at 1 amp under all conditions, similar to that of an LDO regulator. The LT8610 comes in an MS16E package and only requires resistors, capacitors, and one inductor to complete the whole circuit. Let's look at quiescent current. When a step-down regulator converts an output voltage, some input current is required to power the internal circuitry of the IC even when no power is provided to the output. We call this current the quiescent current. Most conventional step-down regulators consume several milliamps while providing no power to the output. This degrades efficiency at low loads. Here is the LT8610 demo board. The input is provided by a 9-volt battery. The output on the right meter reads 3.3 volts out, while the meter on the left reads the 2 microamp quiescent current. We can see this quiescent current at different input voltages here on the graph. In addition, the LT8610 offers low output ripple of below 10 millivolts, seen on the bottom trace here. Transient response remains fast even at low loads. The LT8610 datasheet guarantees input current for typical applications with 100 microamp and 1 milliamp output loads. This is great for customers who need fully specified low current consumption. Next, let's look at efficiency. On the left is a linear plot showing efficiencies at medium and higher currents. You can see here the peak efficiency for 12 volts to 5 volts application is very high at 96%. On the right is a logarithmic plot where low load efficiency is easy to see. The efficiency is over 80% for loads of 100 microamps and 90% for loads of 500 microamps. Looking at both plots, we can see the LT8610 offers industry-leading efficiency over a very wide range of load current. For an ideal linear regulator with zero quiescent current, efficiency is 5 volts divided by 12 volts, or 42%. Compared with the ideal LDO, the LT8610 will have higher efficiency at load currents above 3 microamps. Let's look at switching speed. The LT8610 is capable of high-speed switching, allowing the use of smaller inductors and to minimize PC board space, and it also allows reduction of EMI. Looking at the plot of minimum switch-on time, we see 30 nanoseconds to 70 nanoseconds. This means a 2 MHz switching frequency can reliably be used in applications such as automotive input to 3.3 volt out, allowing operation above the sensitive AM radio band. The LT8610 can also safely use small inductors. This is made possible by high-speed peak current mode plus robust switch design, which tolerate inductor saturation during fault conditions, even at high VN. Inductor choice can be based on specific application requirements rather than maximum switch current ratings of the 8610. For example, if the maximum load current is 1 amp, an inductor designed for 1.3 amps is sufficient. This greatly reduces PC board space because the inductor is often the largest passive component. The next chart shows dropout performance. In many circuits, it's important for the step-down regulator to operate with a small voltage between Vin and Vout under conditions such as depleted battery. On the left is the minimum drop between Vin and Vout versus load current. For example, if the load current is 1 amp, the input only needs to be 200 millivolts above the output. Also important is good behavior going in and out of dropout, seen on the right. The LT8610 behaves like an LDO. The output voltage follows the input until the output is in regulation both during startup and shutdown. In summary, the LT8610 offers many great features all combined in one small IC. This includes wide Vin range, high efficiency, a simple application circuit, and ultra-low quiescent current. For more information, please visit linear.com. Thanks for watching.